This is MBF3C, grade 11 workplace math, college math, and I'm the teacher, Bronwyn Slate. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View channel 972. You are always welcome to join me live through the Zoom link, which is available both from me, your teacher, and also your DEC. Our classes are scheduled from Monday through Thursday, 2 until 3 in the afternoon, and we are in our 6th week of our 9-week course. We actually do not have class this Thursday as Wahsa is closing on Thursday at noon and beginning the winter holidays. So today is the last class of this week, and we will be returning on January 9th, 2023. So hopefully you're able to enjoy a 2-week break and celebrate however you celebrate, whether it's solstice or Christmas or just enjoying a break off. Hanukkah is this week. Kwanzaa happens sometimes around now. I don't know exactly when it happens. There's various joyous celebrations at this time of year, so celebrate well and have a happy new year. And we will be back on the radio on January 9th. Though, if you are going to spend some time working on your math, a reminder that the work to submit are not the support questions. The support questions are there to help you, but they are not for marking, and you can decide which ones to do and how many to do, depending on what your needs are. If you are understanding a concept, feel free to skip questions. That's totally fine. The answers are in the back of your booklet. So I strongly encourage you to check your work to make sure you're on the right track. And then you can possibly figure out if you're going wrong, why you're going wrong. The key questions, the ones with the key icon, are the ones to submit for marking. So please do all of these questions, submit them all, and show all of your work, your steps, and your thinking. This way I can understand what it is that you understand, and if you are struggling with something, there it is more likely that I'm going to be able to set you up for success and give you some support. So please don't just give me an answer, give me all of your work. Okay, so then how do you actually submit your work for marking? There's 3 methods. The first is to scan your work and send it electronically. You can scan your completed work using a device. If you have an Apple device, you can use the Notes app. If you have an Android device, you could use the Google Drive app. These are both free apps that generally come with these devices, though again, they are free if you need to download them. They are basically like taking a picture, pointing and shooting. If you need some support to learn how to do this, on my YouTube channel, I have tech tutorials that walk you through how to actually use each of these apps, giving you step-by-step instructions about how to scan and then send them. So then you can send it to me through email to studentwork@nnec.owen.ca and c2bronwyn.slate@nnec.owen.ca, or you can send it to me through Facebook Messenger, where my name is B. Slate Wahsa. The second method is to drop your work off in Sioux Lookout. We have an outdoor mailbox at 74 Front Street. We are the bright red building next to the post office, and we have a small white mailbox next to our side entrance. The third method is to hand your work into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name B. Slate Wahsa. All of our radio Zoom classes are recorded, and I upload them shortly after airing to my YouTube channel and share them on Facebook. So it's a really easy way to access all of our lessons. All of our previous lessons are on YouTube under a playlist called MBF3C, which is our course code, so you can find them all there. Also, I have created short videos that explain common errors and confusing concepts. So these are good places to start if you're struggling with something, if you're making the same mistake over and over again. Possibly I explain how to improve in a couple of short videos that are just easy to access instead of doing a general internet search. Math is a really visual subject, so I strongly encourage you to access the videos. Just listening to the audio is not going to give you a full picture. You're really going to struggle to understand everything that's going on, as I'm often referring to images that just are going to, it's going to make more sense if you are following along through the video. If you can't join me live through Zoom or access the videos on YouTube, please let me know. And I'm happy to send you a copy of the recording so that you can still get the full experience. So if you have any questions, please reach out and connect with me. My email address is bronwyn.slate@nnec.on.ca. Connect with me through Facebook, where my name is B. Wahsa. Give me a call at the office at 807-737-1488, extension 2209, or toll free 1-800-667-3703. My office hours are Monday through Friday, 9 a.m. to 3 p.m. So if you want to try to get a hold of me directly, connect during those hours, though you can leave me a message and I'll get back to you as soon as I can. All right, we are wrapping up Unit 3 today with Lesson 15. So, which is creating nets. And this is a little bit of a different lesson, but the learning goals are that you will be able to use nets to transform two-dimensional drawings into three-dimensional figures, and you will understand the difference between nets, patterns, and plans. You know that you've met these learning goals because you can visualize 3D objects and the nets that create them, and you can explain what makes a net, a pattern, and a plan. So when we'll use this in real life? Well, we are learning how to see the whole picture. The nets are a representation of something, and so being able to look beyond what you just see is a really useful skill that you can apply and transfer to various situations in your life. So though you may not be looking at nets in your life, being able to step back and take pieces of information and see the whole picture is something that is incredibly useful. But first, let's dive into, before we dive into our lesson, let's activate our brain with some mental math. I don't believe in mad math minutes. They do not set students up for success. They generally cause stress and anxiety and reward students who innately are comfortable with memorization and speed, though these are not tools for deeper understanding in mathematics. So we spend our time developing strategies that we can use in various situations that really are dependent upon comfort and confidence with number use. Our question today is 924 divided by 36, and we're using the strategy of multiplying up. So what I mean by this is that instead of dividing our whole amount into smaller groups, we are going to make groups of our smaller amount of our 36, our dividend, to figure out how many are going to fit into 924. So 10 groups of 36 is 360. So that is less than 924. Okay, great. So if I double that, that's 720. So that's going to be 20 groups. And that's still less than 924. So then I have to, if I do another 10 groups to have 30 groups, I can tell that that's going to be more than 924. So I don't want to do that. So I'm going to think instead, okay, well, if 10 groups was 360, then 5 groups is going to be half of that. So 5 groups is 180. So that means that if I do 25 groups, that's going to be 20 groups plus 5 groups is going to be 1,000. So again, that is too much because 720 plus 180 is, no, 900, not 1,000. I was like, did I do too much of that? Yes, 900. My bad. So 25 groups is okay. So I need 924 divided by 36. Well, another group of 36 is going to be too much, but I can say, well, 24 divided by 36, I know that 24 is, so if I 12 plus 12 is 24 plus another 12 is 36. So 24 divided by 36 is 2/3. So if I do, so 924 is going to be 25.33, sorry, not 3367, because it's 2/3 groups. So this equals 25.67. And that's how you can use the idea of multiplying up. Even when you don't have whole numbers, you can sometimes get a little bit more information based on the numbers that you do have. All right, mine's on. What do we need to know before diving into today's lesson about nets? I just wanted to do a quick review of geometric shapes, as we haven't talked too much about them in our course so far. So a key point is that if you need a formula or you aren't sure what a word means, it is completely okay to look it up. I do not expect all of this information to be stored in your brain. Your brain is storing all sorts of information that is relevant to you day by day, and probably the area of a circle is not something that is relevant to you every day. That's completely reasonable. So if you need some piece of information that you don't know, look it up. That is totally fine. Don't just guess, look it up. Look it up in our booklet, look it up online, talk to somebody else. It's totally fine to need to access other resources because your brain is holding other information. So two-dimensional shapes are flat shapes. So circle, oval, triangle, square, rectangle, parallelogram, trapezoid, pentagon, hexagon, octagon. These are all two-dimensional shapes. They are flat. They have a width and a height kind of idea. They don't all have that exactly, but they're moving in 2 directions. That's what two-dimensional means. So if you run across a shape, you don't know what a trapezoid is, then look it up and you can either guess from the picture or you can find the definition of what it actually is. That's totally fine. It's okay if you don't remember what all of these shapes are. So three-dimensional shapes are three-dimensional. It's really hard to explain three-dimensional without how to define it other than what is three-dimensional. So it's something that pops out, it moves in 3 directions. So you have a length, a width, and a height. So a cube is a 3-dimensional version of a square. So you have each side is a square. A sphere is a 3-dimensional version of a circle. It can be really hard to draw these because you are drawing 3-dimensional things on a flat surface. A rectangular prism is like a cube, but instead of having all the same faces, which are the sides, then you have some, they're going to be different because your dimensions of your rectangle are different than a square where they're all the same. A cone has a circle as the base, and then the sides all come together to a point. A triangular pyramid has only triangular faces. They do not all necessarily are not the same triangles. The base could be different than the other three sides, but they are all triangular. A cylinder, you have a top and a bottom for a circle, and then you connect the circle with a side that's a rectangle. We'll look at that. A triangular prism means that you have a top and a bottom that are triangle, and then you're connecting those two triangles with rectangles. And then a square-based pyramid is a pyramid that has a square base instead of a triangular base or a circular base for a cone. But then you have triangle sides. So again, it takes some getting used to, some practice of what all these shapes look like, and they are tricky to draw. Totally reasonable. They're tricky to draw. It does not have to be perfect if you're going to sketch them. So the other thing we need to know about, other than just what shapes are, is that we need to talk about scale. So scale is a ratio between two sets of measurements. In scale drawings, the ratio of the measurement on the drawing compared to the measurement of the original subject. So we are drawing a representation on our page, on our computer, and it is not the true size to whatever it is that we are drawing. Maybe we are blowing it up and we're getting a lot closer than it really is. Maybe it's a lot smaller than it really is. And so but if it's in scale, everything is in proportion. There's nothing that is skewed. Everything is using the same sort of zoom factor. So here we have a diagram where we have 1:1, which is they are the same. So the sizes are the same. We have 1:2. That means that each dimension is doubled. So the length, the width, and the height are all doubled. If we have 1:3, then each of the sides are tripled. Length, width, and height are all tripled. 1:4, each of the sides are tripled. Length, width, height. So you can see that they are still the same shape. They're in the same ratio to each other, but it's just that the B columns are getting bigger and bigger as we have a larger scale. Okay, so what new are we learning about today? So again, math is always all around us in various forms, and nets actually do show up in different places. Plans and patterns all show up in different places in our world. So anything that is being engineered or built is going to have a plan. You do not just dive in and do it without having any sort of plan or any sort of diagram that has your measurements so that you can come back to it and you know what it is that you're doing. So that is always true of anything that you're building. Patterns in any sort of clothing that is being created, whether or not you're doing it at home by hand sewing or if it's in a factory, again, there's going to be a pattern that is the plan for whatever it is that you're creating, the dress or shirt, pants, whatever. And then there are various things that are nets, which show up in our real lives every day. But we're going to define what each of those means so that we can see them more often in our lives. So first, looking at nets, and this is on page 38 of your IEL booklet. So a net is a 2D representation of a 3D figure that results when the figure is unfolded. So if you take anything that is three-dimensional and you imagine unfolding it, then the thing that you end up creating is called a net. So when unfolded, the original figure becomes a flat shape where all of the edges meet to keep the net as one piece. A lot of three-dimensional objects are created from flat material. So for example, a cardboard box and sheet metal and ductwork are from flat materials and bent or folded to form the objects. So this, most people probably seen somewhere in their lives where you have one piece of cardboard that has been cut and then folded to make a cardboard box. If you unfold it, then you're going to have the net because all the pieces are stuck together. They're all one piece, but just folding it makes a three-dimensional object. So here are some images where this one is, so you can see a net folded up, or you can also have them, you can see nets unfolded. So if we go in, I have some things to show you where, so on Mathigon, which is a website that also has a free app that you can use. So this, you can go into this and actually play with nets a little bit. So nets are going to be under, they should be under geometry, 3D solids. And then you can see here are our various nets. So this is one that I had in my picture. You can move it around so you can see it from different angles. You can see how this works. This is a hexagonal prism because I have base and a top that are hexagons, and then my sides are rectangles. All my sides are rectangles, and then you can unfold it. And then you can see now this is a net. So now all of my pieces are, and I can, if I wanted to, I can, there is a way to, maybe they have changed that. There's a way to, you used to be able to break them apart, but that doesn't seem to be, they've updated that. So, oh, here we go. Now I don't know. So there's various things you can do with Mathigon. Now I've taken apart one of my pieces, and now if I fold the net, you can see, well, I've taken off that top because I deleted that top part. So now it's no longer a net because I'm missing that top piece. Anyway, it's a really great program to go in and play around with. It has all sorts of various shapes. It doesn't have all of them, and that frustrates me because it doesn't have like anything with a circle. But it does have lots of other tools that you can, and now you can see now that it won't, this isn't a net anymore. My pieces aren't all touching, so it won't fold it. It's not a net. Okay. Then we also, this is another link where we go into GeoBra, and there are a bunch of different nets that you can, this one has some circle nets. So you can see, you can change the size of things is one thing that you can do that's kind of fun. It is a little glitchy today. I don't know why, just because that is my life. And then it shows you how it unrolls it to turn the three-dimensional shape into a two-dimensional flat object, which is pretty cool. So there's a cone, there's a cube, there's a square base pyramid, and then there's also a cylinder. So you can see how it goes from three-dimensional to two-dimensional, which is just a great visualization. Remember, lots of folks need to be able to see it to understand it. Totally reasonable. So I'll link those in our show notes on the YouTube video so that you can check those out if you'd like to. Okay, so that was nets. Patterns are another two-dimensional representation of a 3D object. So we're still talking about the same thing, but this is when we separate the figure into two or more individual shapes. So now instead of everything being attached and being able to be refolded, a pattern, the pieces are not attached. So for example, when you take a piece of clothing and you take it apart at the seams, all of the three-dimensional shirt or pants that you had before now is going to be in its pattern form because it's no longer attached, and you can't just fold it back up into what it was before. It's, you're seeing the pieces instead of the whole. And you can also do this on Polypad, is that you can take a net and then you can move things around so that, like, if we were trying to create this hexagonal pyramid from a piece of cardboard or a piece of fabric, and we wanted to use the least amount as possible, so we didn't want to take a whole piece of paper and cut out all of the triangles from it, we wanted to try to make it not use up as much paper. So then a pattern would take all of these triangles and put them together so that you don't have to use as much paper to get them really close. And then that would reduce your material costs, which is often really important. So we still have all the pieces that we need to make, but they're just cut apart and put close together so that you can't just fold them back up. And then we have plans is our third type of tool we're talking about today. So this is a set of orthographic views. So from front, side, and top, it's used to describe an object to specific dimensions. So plans, or they also could be called layouts, are used so that one can construct something to specific dimensions. So it's important to have on plans, you need to have the dimensions written on them. So an example is a blueprint for constructing a building. This is a plan. So here you can see I have 3 views. I have one object. Doesn't look like I just have one object, but I have one object, and I have the side view. So looking at it from the side, looking at it from the front, and looking at it at the top. And then I also have the dimensions written on here for each of these. So then you can even see that, well, this top view, this length is going to be the same as this one here because they're the same. They're both 22. So kind of having the dimensions helps you visualize how this is going to look. It's going to look kind of like a chair. So then here is the 3-dimensional what you're constructing from the plan. You should be able to construct this little chair from this set of 3 pieces where you have the side, the front, and the top. And then now you should be able to create this little chair that would be the same as any other little chair that use those plans. Here is another example where you have a top view, a front view, and a side view. Again, you have your dimensions, so you can see this top view doesn't look like there's anything sitting on top. It just looks like maybe this is a circle that's cut out or something. But then here from the front view and the side view, we can see that actually sticks out. And then so our image would look something like this if we were to actually build it. And that is the basis of this lesson. So you can do the support question on page 38. There's only the one question. They can be a little bit funky. I strongly encourage you to use the Polypad, the Mathigon Polypad system to go in and try to create the nets because it is really hard to visualize. That's totally reasonable. Play with them though. So let's do some practice questions to figure out how this might be useful and how we would attack these sorts of problems. So practice question number 1, draw a 3D diagram of a box with dimensions length 20 centimeters, width 8 centimeters, and height 30 centimeters. Now, when the length, width, and height can sometimes be tricky to know which one it is. Height, generally, when we're drawing it, is up and down. It's like a vertical point on our page, but length and width really can be, I'm not ever super attached to which one you define to be the length and which one you define to be the width. This is why it's really important to label things so that we know what it is that we're talking about. So drawing a 3-dimensional diagram of a box, drawing a box can be challenging. I am, as we all know, not awesome at this. I am best with a pencil and a piece of paper. Doing it on a computer is particularly challenging. So you can draw a box in a couple of different ways. I've drawn the front face, front side, and now I'm going to label my sides so that I know what I'm talking about. So this is my length, 20, and my height is 30. My height really is actually bigger than my length, which is great. This is not to scale. This is just to rough idea. So then, so that it's 3-dimensional, I'm going to go back on an angle And I'm going to go back from each of my corners in the same direction to the same angle. And then I'm going to connect those back pieces so that I can see that I have a three-dimensional box. You can do your inside pieces. You can do solid lines or dotted lines or no lines at all, whatever works best for you. And then this direction here is 8 centimeters. And that is how you would draw a three-dimensional box and labeling your dimensions. So part B, use the 3D drawing to create a net of what the box would look like if it was unfolded, including, again, dimensions. So I'm going to draw a quick sketch again of my box. This is not going to be perfectly exactly the same, and that is fine. I'm going to draw I'm going to label my sides again, the same places, the same directions, so that that's at least consistent. Okay, so now I need to unfold this image and make it a net and label it. So I'm going to say, okay, well, I'm going to start with this bottom piece, and this bottom rectangle is 20 by 8. And you don't have to write centimeters every single time. That's fine. And then if I were to cut along this long piece that goes up, that's still going to be 8 centimeters if I lie it down. But now its other side is 30 centimeters. And then the top again is a 8 by 20 centimeters. And then one last 8 by 30 centimeters. When you're doing a net, there are various ways. You are very possibly not going to do the exact same one as me, and that's totally fine. There's no need to do it exactly the same as me. As long as you're labeling it, then I know what it is that you are intending. So I've done the top, the sides, and the bottom. So I need to do the front and the back. Well, the front and the back are 20 by 30. So that means that I need to go to a 30, and then I'm going to draw approximately the 20, which is going to be kind of like this, because this is going to be attaching to that, right? And I'm going to label that 20, and then I'm going to do the same thing over here. Again, there are different places you could put these things, and that would be fine. And also, it does not need to be perfect. Oh, see, I tried to improve it, and it is the same awfulness. And that's one way that a net could look for this three-dimensional box. You do not need to label every single side. You just label the ones like, so this 20 applies to this side and to this side. This 30 applies to all 4 of those sides. This 8 applies to all of these sides. So it's okay to not label every single one. You just have to make sure that you're labeling one in that direction for that piece. All right, number 2, sketch a pattern that could be used to cut out the pieces of a hoodie. So again, you can see the joy of my drawing. If I think about a hoodie, now it's going to have, I'm going to say that it's got a long sleeve. So, but the long sleeve might actually be sleeves. So I might have a rectangular part for the back. And I'm going to label it back so I know what I've already done. And then it's going to have a front, which is going to have some sort of neck. And then it's going to have 2 sleeves that are going to be kind of triangular, kind of rectangular. We're going to say these are tight sleeves for this hoodie because my sleeves are not very big. So, because I think these are unrolled. And then we need the hood, which is going to be something like a half circle a little bit because it rolls up and then gets sewn to the top here. So again, not beautiful, but the right idea. So then this is sleeve, right? We'll need to label them sleeve 1 I think I spelled sleeve wrong, but sleeve 2, and then hood. And that's how you would draw a pattern. Number 3, a bakery needs a new cylindrical package for their oatmeal cookies. Each cookie is about 1 centimeter and has a diameter of 8 centimeters. So that's 1 centimeter thick. Find each package. Each package should hold about a dozen cookies. Draw a net that can be used to make the package. So first we need to figure out how big is our vessel, and then we can draw our net. So we know we're going to make a cylindrical tube, and it's okay if it's not beautiful. So we know that it has a diameter of 8 centimeters. So that means that this distance is 8. And each cookie is 1 centimeter. So we know that once we get all of our cookies, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so each of our 12 cookies is 1 centimeter thick. So that means that this is going to be, it needs to be 12 centimeters tall. So now we have our package that has our cookies in it, and we're going to take this big piece and we're going to unroll it, and it's going to be a rectangle, and it's going to be not like that. This is 12, then this is 8, because the diameter, no, this is not 8, right? So why is this not 8? Well, because the diameter is 8. So that means that the circle that touches along here is 8. And there's a circle for the top too. But is that the part that touches the rectangle? No, the circumference touches the rectangle. So we need to find the circumference of the circle, which is like the perimeter. And the circumference is equal to 2 pi r, or 2d pi, right? Yes, there's got to be pi in there somewhere. Not 2d. There we go. I was like, this isn't right. Diameter times pi. There we go. Okay, so the circumference is going to be equal to 8 times pi, which you can put in your calculator as 8 times 3.14. So let's get our Desmos out. So 8 times, and your calculator probably has a pi button on it. Looks like this. So 25.13. So then that means that this distance here for our rectangle is 25.13. And that's how we figured that out. So here we had to use the information from the circle to figure out the information on the rectangle. All right, and those are my practice questions. I'm just going to look at the one support question that is in your booklet because it's a little bit weird, and how do you figure it out? So it says below are examples of nets which will produce a closed object, and explain why the others will not. So what I like to do is actually, you can go to Geobra and look to see the ones with the circles to see if they will work. Or you can go to the Polypad and that must be locked or something. I don't know. Why won't you delete? Just refreshing to get a new page. So you can go to Polypads and then you can figure them out. So you can take pieces. Now you are going to have to take, like, you can't necessarily totally build the ones that are there, but you can try. I don't even know. So if I unfold this one and then I delete these because I want to have a triangle. So I'm trying to get this one. So I have three, oops. I have three rectangles and two triangles. Oops. Easy to press copy instead of delete. Just super fun. If I line them up, is this going to make a net? That's what we're trying to figure out. As you can see, sometimes they do snap. To each other if you have them at the right angle, at the same angle. So this is what I mean by using Polypad to try to create your own, to create the nets that are in here. Oops, sorry, didn't mean to click there. And now, oh, that's not quite attached. You need to it kind of clicks in. You can feel it. And now I'm going to fold it, and it did fold, even though it's not the one of the ones that they created that we can choose from. I was able to create take one of my nets, my net E, and I created it. And now I was able to modify, like you can see that this is trying to get the same orientation, but it's a little bit tricky. It doesn't care. This is the way I built it, I guess. You can see that this is the same shape as that. And so this E will work to create a net. So you can do the same thing with the other ones, is that you can take the pieces. Unfortunately, the circle ones you can't do that with, but for the circle ones, you can go to the GeoBra link and you can look, there's a net of a cone and a net of a cylinder. And so you can look at the ones that have circles here to see how they work. All right, let's consolidate what we've learned today. So lesson 15 is creating nets. So we looked at nets, which are the flat version of a 3D object that can be folded to create it. So all of the pieces are attached in some way. Patterns are a flat version of a 3D object with the parts separated. So it's similar to a net, but instead of the parts being attached, they are separated. And a plan is a flat version of a 3D object that shows the front, side, and top views so that it can be constructed along with dimensions, right? So we can look at this and looking at the picture, we can know what it should look like. Okay, so hopefully you can visualize 3D objects and then also the nets that create them. This can be the tricky part. And you can explain what makes a net, a pattern, and a plan, differentiate between the three of them. And that is all today. So today's lesson is a little bit shorter than usual. Lesson 15 doesn't have quite as much as some of our previous lessons, but that's good. Sometimes you just need a break. So if you have any questions, feel free to give me a call. Remember, as of December 22nd, we will be out of the office until January 9th. So you can still send me an email or give me a call and leave me a message or send me a Facebook message. I will not receive them or respond until January 9th. But this way, if you have questions, feel free to send them. You don't have to wait until you have all the questions. If you send a question, you figure it out, no worries, it's all good. Do whatever works best for you. So give me a call before the 22nd or after the 9th to talk to me directly or to leave me a message between those times at 807-737-1488, extension 2209. Call toll free at 1-800-667-3703. You can also email me at bronwyn.slate@nec.on.ca. Connect with me through Facebook at bslatewasa and at YouTube. Remember, all of our lessons are up there under a playlist MBF3C. Also, my channel is called Wahsa as well. Thank you so much for joining me today. I hope you have a lovely holiday if you celebrate such things, and just enjoy the cold weather and the winter if you do not celebrate anything this time of year. Thank you so much for joining me. Miigwech.